What is an activation function in robotics neural networks? Imagine a robot trying to recognize objects or decide how to move. Behind the scenes, neural networks help it make these choices. But how do these networks decide when to activate a neuron? That's where activation functions come in. They are like decision makers for each neuron in the network. When a neuron receives signals from other neurons, it sums up these inputs, often with some weightings. The activation function then takes this sum and transforms it into a specific output. This output determines whether the neuron should pass its signal forward or stay quiet. Without these functions, neural networks would only be able to perform simple linear tasks. They wouldn't be able to handle the complex patterns needed for advanced robotics. Activation functions introduce nonlinearity, which means the network can learn and model complicated relationships in data. This is essential for robots to recognize objects, plan paths, or adapt to new environments. For example, in robotics, neural networks process sensor data to help robots navigate or manipulate objects. Activation functions help these networks learn faster and perform better. They work by taking the total input, which is the sum of all signals plus a bias, and applying a mathematical transformation. Common activation functions include the sigmoid, which maps inputs between 0 and 1, making it useful for probability estimates. The hyperbolic tangent, or tan, maps inputs between -1 and 1, centering the output around 0. The rectified linear unit, or ReLU, outputs 0 for negative inputs and the input itself for positive inputs. ReLU is popular because it speeds up training and reduces issues like vanishing gradients. Choosing the right activation function can make a big difference in how well a robotic neural network learns and performs. For instance, ReLU is often used in deep learning models that control robotic perception and decision-making because it allows the network to learn faster and handle complex data more efficiently. In summary, activation functions are vital parts of neural networks in robotics. They help these systems learn, make decisions, and perform complex tasks by adding the necessary nonlinearity. This capability is what allows robots to operate intelligently in real-world environments, making them more adaptable and capable of handling the challenges they face.